I think we can begin now. Thanks again for being here with us today. This is the webinar, How Alstom Boosts Their Business with Additive Manufacturing. Basically, how to scale up additive manufacturing in the business. You have a box in the bar in front of you. That's something all the participants have. So please type your questions during the webinar. All questions are good questions. There's a Q&A box for that. And we will be very happy to answer the questions at the end of this webinar. But please feel free to type the questions during the webinar, as I mentioned. We would like to get to know you a bit more before I leave the floor to our amazing speakers today. So we have a couple of very quick questions for you to break the ice before our speakers begin their presentations. You're going to see a poll popping up. And the first question is about the industry. So are you already using 3D printing technologies, and in which industry? Wow, I see that lots of people are voting, which is great. More answers to these questions. Thank you for this. About 60% of people have voted so far. Amazing. Okay. I think we have a good sample now. So about 28% of people are from the railway industry, 20% aerospace, 15% consumer goods. Automotive is quite high as railway, 25%, and others is the other half of people. Thank you for this. We have one more question to learn more about you. We are curious to know where you are in the additive journey now. So do you still have to begin this journey? You are just about to begin the journey. You're using 3D printers for production and prototyping, prototyping and tooling, only prototyping, tooling only. Once again, all these answers are anonymous, and it's just for us to understand more about you and to make sure that these contents fit your needs the best way we can. Wow, lots of people are voting. This is great. About 65–70% of all the attendees has voted so far. Great. Thank you for this. This is very interesting. I see more and more people are voting. Please vote. This is helpful for us. We really want to get to know you more and more. Great. Thank you for this. So about over 30% of our attendees today are using 3D printing for production, prototyping and tooling. Then about 28% of the people who are here with us today still have to begin their journey, which is great. We really hope that this webinar will be inspiring for you. And then we also have other people using 3D printing technologies for prototyping only, and for production and prototyping as well. Great. So now that we know a bit more about you, thanks again for this, I would like to introduce you to our speakers today. First of all, I am Lisa, and I am the marketing manager for Europe here at Markforged. We also have two other people from the Markforged team here with us today. We have Fabrizio, who's the sales manager for Southern Europe here at Markforged, and Jocelyn, who's the application engineer for Southern Europe. And I'm very happy to introduce you to our speakers coming from Alstom, Mathilde and Aurélien. Mathilde is the 3D printing specialist at Alstom, and she's based in the Valenciennes site in the north of France. And Aurélien is the 3D printing program manager at Alstom, and he's based in Paris in Alstom HQs. And now I'm very happy to leave the floor to Aurélien for his presentation.
Hello, everyone. I'm very, very happy also to be with the Markforged team and with all of you. I would say that quickly, I would like to present briefly what is Alstom. For sure, you know that we are proposing smart mobility solutions, green smart mobility solutions. We are also a key player for the railway industry, and we are presenting a lot of innovative solutions. Since 2016, we have the ambition to propose a 3D printed part to our facilities and also to our customers, internal and external ones. And that's why we are here today to present you the update on this strategy. Some key figures. We are more than 70,000 people all around the world. Our footprint is a global footprint with several regions. As said, Lisa in introductions, Mathilde and I, we are located on the Europe regions in France. And regarding the additive manufacturing patent, we have several patents also dedicated to this new technology to try also to secure our knowledge and skills. Let's now switch to what are the technology possibilities and opportunities for Alstom. So thanks to the 3D printing R&D program, we succeed in, I would say, mastering the tooling, mockup, and prototyping. And we also have aluminum 3D printed parts, safety one, validated by our, I would say, historical operator that is now rolling on train. Okay. Based on all this successful experience, in the next 3 years, we will have more and more material validated. I have a breaking news at the end of the webinar for you. We also develop some topological optimized design. We do some heat exchangers. We also we are printing bigger and bigger parts, polymer and metal. Thanks to the technology, and we also work on the digital warehousing to be able to propose whatever your location in the world, the 3D printed part. In the future, you know that it goes faster and faster, bigger and bigger, and we will follow this trend. That's why it's very important to invest in this topic. Next slide. Regarding people often ask me what is the digital maturity of additive manufacturing. In fact, we have 3 main businesses in Alstom that are using additive manufacturing: tooling and proto, spare part, new design. On the first one, I would say it's close to be a no-brainer. Okay, when we decide to do prototyping and tooling internally, make strategy, it's affordable for everybody. We win money and time, and we are now spreading the good news and the adoption of this technology through the regions. And it is for several sites, like for example for Valenciennes, where Mathilde is located, business as usual. The spare part, it's I would say now my new challenge. Okay, in the next 3 years, I will have to develop this topic, this business. Okay, with all the knowledge we have and the skills also internally. And for new design, each time the design office decide to go for additive, it's for performance enhancement. pressure drop reduction, noise reduction, less weight. Even if sometimes it is the cost is higher, but it's a global total cost of ownership that is analyzed. These three businesses are supported by three enablers. So the three enablers are materials, R&D. When we prepared the webinar, I said to Lisa, Fabrizio, and Jocelyn that imagine that in 2016 we were printing some pen holders. Okay, now we are doing some validation on fatigue for metal parts. So it shows you the switch and the financial effort that Alstom is doing by now. We are also working with the second enablers, that is IS&T, method and tools. We need a strong integrated 3D digital chain, including additive manufacturing. And the last but not least is sourcing and quality. We need some key players, a good partnership for the OEM, for to develop some printing farms. And it will become in the next month commodity as, for example, welding or other conventional technologies. Let's now discover the stream. Yes, next slide. So regarding the stream, today the good news is that all the platforms, when I say platform, what is a platform? It's a light rail vehicle, high-speed trains, locomotives. Okay, all the platforms are onboarding additive manufacture parts. As I said, we are doing tools, spare part, new design. On this webinar, we will focus on tooling, even if we will speak briefly about the two other topics. We are mainly for jigs, a good application, a good material is the onyx, or the white nylon. Maturity is very good, very high. Each time we are winning money. It's as I said in introduction, it's non-brainer. And for I would say end-use part like spares or new design, we are very interested in the continuous fiber use. Okay, whatever carbon, glass fiber. It is strong like metal, okay, strong as metal, and also it helps us to reduce the wearing of the parts. And this will be explained by Mathilde. Now you will see. So Mathilde is working in our team of specialists and experts. She has a high skill knowledge of additive manufacturing. So Mathilde, please present us a golden use case you developed in Valenciennes. I leave you the floor now.
My pleasure. Good morning, everyone. So as Lisa said, I'm Mathilde Pillier. I'm a specialist on the Valenciennes site in north of France. So I'm happy to present you this use case. So it's on the metro for Paris. It's a tool. And so this metro is manufactured on the Valenciennes site. And so the purpose of this tool is to adjust the lateral profiles on the roofs. You see it with the red arrow. And it's to avoid the bending of the profiles. So the first part was designed for the first time in 2016. It's still used online, and they requested a duplication in 2020 because of the increasing of the pace of manufacturing. So they requested 2 more parts. So we did it. So as you can see here on the image on the right, there is 2 here in nylon white, so PA6, and 1 in onyx. So in this case, we made it in nylon white. Lisa, can you go on the next slide, please? Thank you. So in nylon white, we add some continuous fiber carbon in wall to ensure resistance. The most important point of this tool is we have to add magnet to avoid the fall of the tool and to avoid hurting operators. So to do this, in the design, we made 2 holes. The dimensions are magnet's diameter plus 0.5 millimeters. And it's possible thanks to the Markforged 3D printer, because first we are able to make some pause. So 3D printer will keep the good temperature of the printhead. And also we are able to take out the bed of the 3D printer and to place it at the exact same place in the machine. So print head will continue the printing at the exact position. So as you can see here, the total printing time is 1 day and 4 hours. The pause is at 1 day and 2 hours. So at this point, I just have to take the bed out, remove the support inside the part, add the magnet, and put back the bed. 2 hours later, part is ready. So another strong point is we are able to add off-the-shelf components like here magnet insert. So this is really good for purpose. So can you go to the next slide, please? Thank you. So as you can see, it's a very good tolerance to ensure adjustment of the profiles. And this is an important point for tooling. When people request tools from me, they request some tolerance, and I have to respect that. It also have a very good resistance, and it's important because it's used every day. And like the pace of manufacturing is important, we need that the tools does not break during the day. And as you can see on the video, using this tooling, there is no damage on the car. The metal is good, the paint is still good, but the magnet is enough strong to ensure there is no fall and to not hurt the operators. So here's this use case. So I'm proud to be able to help our operators and the company with 3D printings and to be able to answer very quickly to their request and their needs. So Fabio, the floor is yours.
Thank you, Matilda. It's a it's a pleasure for me to be here, and I'd like to thank Alstom for the opportunity. For me, it's important just to give some details about the core strength of our technology, why it's so different, why it's so unique, and what are the capabilities that you can obtain when you introduce a Markforged technology in your production, in your environment. The company was started with a very simple idea. It was to be able to reinforce with continuous fiber a part printed with 3D printing, with filament-based 3D printing. You can see here on the right picture, the yellow is a Kevlar fiber, so it's a Kevlar filament, and it's been iron anchored inside a part, inside a matrix material, in our case onyx. And you can see also on the drawing of the printing head, the two different nozzles, one for the matrix material, the skin, the shell that protects the fiber, and the other for the continuous fiber that you can layer inside a part to build this inner strength. It's like you can decide how to build the skeleton inside a part. So if we go on the matrix material, so the base of our part, we have different material, all produced internally in Markforged. So onyx is our core material, is a nylon-based filament, and it's loaded with chopped carbon fiber. So it's already a great starting point in terms of stability, chemical resistivity, and so on. We also produce different iteration of the material. For example, onyx FR, so it's a flame retardant, is a certified blue chip ULV0 at 3mm thickness, that gives the good reliability against flame. It is very important for automotive or railway customer. As Alstom. We also have a new iteration called Onyx ESD. It's as a shielding material for electrostatic discharge. So it's very interesting for a PCB market automation where current is involved. So all of this basic matrix material can be then reinforced with continuous fiber. And we do have 4 of them. We have 4 of them because each fiber has its unique properties, and now you use it inside a part that can give you different strength. So carbon fiber is the strongest, the more rigid, the one with the best mechanical strength, and you can often replace aluminum parts for the lightweight and the mechanical strength. We also have Kevlar, like in this case, it's a bright yellow aramide fiber, and it's a very interesting fiber. It's the same that you use for a bulletproof vest, for example. It never breaks. It can bend, but never breaks. So it's very useful for against failure. So you know that a part will never snap, will never break, will bend, will be very safe. And then we have fiberglass and fiberglass high strength, high temperature for a good compromise between mechanical properties and cost of the fiber. Well, when you think about composite, you always think about the fabric, the autoclave, the resin. We don't have any of these here. We are just working with the filament. So we also can decide where to put the filament, in which part of the component, what kind of function we want to obtain. Often with 3D printing, we are asked to replace part or make something through the printer. It's the best way to approach 3D printing is always to think about the function, the objective that you have. So in this case, for example, if you have a compression load or a bending load. So if you think about the function that you want to obtain, it's easier to approach 3D printing with a better point of view, more open-mindedness. All these kind of different strategies of versus compression, impact, bending, abrasion can be obtained using the fibers, one of them for the best case. And we can be sure to use just the right amount in the right position inside the part. So sometimes you can use much less fiber and have the same mechanical properties of a composite part, a traditional composite part or a metal part. It really gives you more, it's another tool in your toolbox, so to speak. And we have seen many applications for our technology. We have starting in usually it's tooling and fixture is our say starting point. Our a lot of application there because it's very easy to replace metal. You have a softer shell, so onyx is still a thermoplastic, so it doesn't scratch, it doesn't ruin that metal like in the case of Alstom. But at the same time, you can build this inner strength inside with this rigid skeleton. Also, because of the lightweight and the strength of composite, you can have an interesting application in automation, grippers, end-of-arm tools, because you can have a lighter payload, something that doesn't ruin the part that you're moving or you're manipulating. And at the same time, it's cheaper and easier to produce. And also, you can produce on the spot. Again, with 3D printing, this mini-series, unique parts or very highly customized parts are ideal. We are discovering more and more application, and as we talk with our customers, we are surprised how our customers use our technology to achieve certain things. In the next slide, maybe I can give you some a quick idea about the capabilities, the limit that we can reach. For example, on the left, on the composite strength, it's a very interesting case for a Finnish company called Wärtsilä. It's a case we have developed in the Italian site. In this case, we're replacing a lifting tool. The lifting tool was made in steel, was more than 30 kilo of weight, so you needed 2 people or a forklift to move around, and it was needed to lift and move around this piston, huge piston with 200 kilos of weight. With a little bit of optimization in the design to really leverage the strength of the fiber, we optimized this tool from a flat design to this 45 angle that you see in the picture, but really you see the skeleton of carbon fiber running through and really able to distribute the load, distribute the weight during operation. We produce the tool. The tool has been tested under load up to 1,000 kilo of weight without breaking, and it's been certified and a safety factor of 4. So it's been certified to lift this 200 kilos piston. What's very interesting that is it's very light. It's like less than 2 kilos as a lifting tool. So we have seen a case in which this tool was disassembled, put on a drone. The drone was flew over the Singapore Bay to reach a ship that was broken down and needed this lifting tool to replace a piston. So this is and the part was produced digitally because it was designed in Italy, produced a few times in Finland, then again produced in Singapore for the need. Another very interesting application is the field of maintenance and repair. I know that many companies are able to optimize to have a quicker setup time to build a more resilient and a more quick to reply production line thanks to this the unique properties of our technology. Sometimes we also know of customers just maybe they have an installation they have to do repair. They just take the printer and they drive the printer to the site, or they produce the part on the spot at their customer, or even in the hotel the night before a meeting. This is our printer a very simple concept, but at the same time, thanks to the connectivity, the material, and our digital platform, it's very easy to use them all over the world. And one last example I wanted to give is this end-use part, because the final target of 3D printing will not be to replace traditional manufacturing. It's going to be to enhance it, to complement it. So sometimes it makes sense to use a Markforged technology. Sometimes it makes sense to use a traditional manufacturing. It's really, you have more option now. On this robot arm, we replaced more than 200 metal components with roughly 70 components made in composite. So a lot of design complication was removed. We were able to put together multiple functions of multiple common components inside a unique, more unified components. The robot arm was lighter. It was more efficient. It was also cheaper to produce. And now you see this customer of ours, Additiven Dynamics, you see the same arm manipulating the part inside to take the part after they've been printed. So they'll be mounted on rails, and you see the video of this machine building themselves. Basically, it's very, very interesting. So this is something that we are always ready to explore together. Just wanted to give you a little bit of visibility into the many applications in which Markforged technology can give value and can be much a competitive advantage for you. It's like a next gear in a car when you really want to go somewhere that you were not allowed to go before. After this, I'd just like to thank everybody again and pass the word to leave the floor again to Aurélien, Lisa, and Jusnan for our Q&A session. Thank you so much.
Grazie mille, Fabrizio. Merci. Yes, regarding our you can see that with the example of Fabrizio, Alstom is, I would say, on the same way. All the industry for jig and tools, it's a non-brainer. It's very cost-effective, and as you said, and as Mathilde shown you, it's I would say small but smart. You see what I mean? Because you see that the jigs presented by Mathilde was not it was not possible to do it by a conventional way of manufacturing, because we are embedding function and we are enhancing also the toolings. So this is very important. So yes, as a conclusion for Alstom, 3D printing is a promising, an amazing journey. I'm very proud to share with our team, our specialists, our experts all around the world. So the journey is continuing. We are spreading the technology all around the world. We will set up new printers in the plant each month, okay, regarding toolings. And we have three main topics. We will continue to develop our skills regarding simulation also. We will print, and we are already printing bigger and larger parts, okay, for more than 1 meter now. And we are more and more solicited by our end use and our customers, operators, okay, of trains. And that's why it's really a solution for our businesses, in fact. Yes. So Lisa, I give you the floor for the Q&A session now.
Yes, great. Thank you. Very interesting. Let's have some Q&A. And I actually have a question for you, Aurélien. What are the next 3 priorities for Alstom in the manufacturing journey?
Very interesting question. So regarding the priorities, I would say there is the first one. We want to push forward the adoption for spare parts, okay? Because we think that today the maturity of the market, the maturity of the printers, and are very high. That's why we can print spare parts for internal and external customers. So the very priority is that spare part first. The second topic is that the priority is to be sure that the new printer X7 and the other one will be successfully installed. And I count on Jocelyn also to work with our team to deploy that, because we have ESD issues. We need stronger jigs. Okay, so this will be also I would say a tomorrow priority. Okay, a short-term priority. And I would say the last priority, for sure, it's to onboard and use part in the train. And the breaking news, I would say now I can share with all of you, is that the Onyx FR, so fire resistant, is now qualified for railway application regarding our fire and smoke standard, the EN 45545. So we reached the R22 HL2 level. So I think that for the 28% of people coming from railway, they will be very interested in this news, because now you can switch to jigs too and use part, and thanks with the Markforged. And I think it's a huge door that we are opening with this qualification and the spread of this technology.
Wow, amazing. Thanks for sharing that. Amazing news. Thanks again. There's also a question. Thank you. There is also a question for Mathilde. Mathilde, what's the trend you see in 3D printing applications?
On my side, mostly for now, we are making a lot of tools and jigs. We are pushing to make lot of prototyping to qualified part before series, and we are making some mock-up to present to customers and have their feedback regarding our design. So yeah, tooling, prototyping, mock-ups, that's most 3D printing part on Valenciennes side.
Very interesting, thank you. So Ruslan, I think there are more technical questions coming, right?
Yes, we have a couple of questions. So I will ask some question to Alstom, to Aurélien or Mathilde. There is a question related to the supply chain, and how did you identify some parts that are good for additive manufacturing? Maybe with the lead time or the cost per item or something like that. So how did you start the journey, and how did you identify the right parts for technology?
Regarding supply chain, so if I understand well, the question is about the lead time reduction, or if I understand well, or also how we identify the part. So for this topic today, the last 3 years we were more on an opportunistic way of working. Okay, I mean, people know that we are able to print parts, so they contact the expert or specialist on site and say, okay, is it possible to print that part? Okay, but we developed since more than 1 year a dedicated, I would say, methodology, okay, to screen the bill of material. Okay, so this is our knowledge, but we have about 20 fields, okay, coming from métier, coming from our ERP, okay, and we do some big data, okay, correlation, and at the end we are able to say, okay, on that project, go straight to this family of part, and you will save money. And the level of saving is more than it's about millions, okay, no thousands of euros.
Okay, thank you so much for your answer, and I think that's related to the next question. So what is your experience, and what are the issues that you have to deal with by switching from a third-party supplier to an internal production?
Okay, Mathilde, do you want to answer to that, or just?
Yeah, I can. For the part of tooling, for tooling, I have a big advantage it's that I can make this part really quickly. So usually you will need some, I don't know, 2-3 weeks to make to buy the part, to find the supplier, to make some contract. I can do this kind of part in 1 week, less usually. So for tooling, for industry edition point of view, it's really the delays that allow me to be better than go externally. For prototyping too, and for mockup, I'm working on this subject to prove that it's important to test and to prototype and to mock up before the serial part, because usually we found some, I don't know, problem or amelioration that we could do. So for this not serial part, prototyping, mock-up, tooling, it's really on the cost and the delay that I can prove that 3D printing, internal 3D printing is really the best solution. For serial parts,
make. Yes, the business model for jigs is make. No other way to win time and money and lead time.
Yeah, exactly.
Okay, thank you so much. Maybe it's a question to Mathilde, also related to the jig. Do you have, and can you share also a rough cost of the jig, including the printing time?
For the printing time, my times, and the material, the raw material cost, it's around 250 euro. The good point is I'm able to do it. It's like the last question. The really important part is a delay. If you request this part on Friday, I can deliver them on Monday. So we are cheaper than go by supplier, and we can launch the part on Friday and have it on Monday. So it's really quick.
Okay, great.
If I can add something to this in terms of like the bill of material and the cost, the machine run without supervision, so there is not a human cost hours during the production. The electrical consumption is very little. It's more like an appliance, honestly. And so you have no operator fee. You have no big electricity cost. You don't have CAM programming, because when you load the part, the CAD part design on the system, the same material, then you can start printing. So basically, the cost of a part is just the material, the base material, and it's calculated by the software punctually every time. And then the amortization of the machine. Is the machine in Alstom, the one we've seen, is from 2016, so it's 5 years. We usually suggest 3 years for amortization, but 5 years also works very well. So it's a very little cost, and you can have great savings when you replace metal or other outsourced part, not only for the mere cost, but also in terms of reactivity and speed and flexibility. It's very easy to design something during the day, maybe iterate it a couple of times during the day with the short printer, then maybe launch a bigger printer before going home, and then the morning after, or maybe the Monday morning, if it's a big printer, you just come back and the part is ready for you.
Exactly.
Thank you, Fabrizio, for this complementary information. I have a question, by the way, for you. It's the first question about the how to guarantee the reproduction of the 3D printed part, the quality of the 3D printed part, and how we ensure that it fulfills the technical requirements. If you would like to take this one. Yeah.
This is another very quick reply, another differentiator between us and other technology. We really want to be focused on the industry and industrial application. So we have seen that for many customers, reliability is important, but they just don't trust reliability. They just want to have a verified controller. So sometimes it happens that a customer print a part and then they have to wait for the quality controller to check the part with scanner or other system to be sure that the part is exactly online. So maybe you lose a little bit of the reactivity of the speed of 3D printing because you are waiting for a control, a quality controller later on, usually done by another office, another department. So this can add days to the delivery and the start to use a part. For this reason, on our industrial series, we have launched a new platform, a software platform called Blacksmith, that is able to inspect the part what is produced, and at the end of the printing, to produce a report, a precise dimensional report with the tolerance guaranteed by the part. So you're incorporating the quality control inside the printing. So you can skip the quality check after the print because it's already done during the process. And that is something that for a large organization with very high quality control has been very useful. So, and we're looking forward to put additional functionality in Blacksmith, but this at the moment is really the core strength, the ability to guarantee and produce reporting for quality during and after the production.
Thank you so much, Fabrizio. I have a couple of questions for Aurélien. It's more related to Alstom and the global offering. Do you have a plan to deploy that to the UK? And the person is also asking about something related to work in parallel with Bombardier on 3D printing projects.
Okay, so I will answer to the first one regarding the merging. So now, in fact, there is no more Bombardier, no more Alstom Transport. It is new Alstom. Okay, so we are now a big family. Okay, so integrating these people and skills. Okay, very complementary skills. Regarding additive manufacturing, it's important to see that we are now able to merge also the skills from Bombardier. Okay, so we will have a bigger community, sorry, and this is very important. And regarding, I think Jocelyn, you asked regarding the offer in the UK. Is it that, or how we sell part? Or I don't understand the question.
The question is, has any Alstom 3D printing offering been deployed in the UK?
In fact, it's not only in the UK. In fact, it's a global offer. And I invite people. You can go on. We have our own railway marketplace. Okay. That is called station-1.com. Okay, and you can find a lot of equipment, spare parts from, I would say, the gel for the COVID for the workers, or to the air conditioning pack, that you can buy. And if you type on the search bar 3DP, like 3D printing, you will find more than 50 references of 3D printed parts, okay, that you can buy and that are already validated for tramways, for metro, okay, plastic and metal. So also, whatever your location in the world, please do connect to the Station 1 marketplace. I would say problem, and if the part is not available on the marketplace, feel free to do your own inquiry with the dedicated link, and we will answer to your need for reverse engineering, print to see the cost of your part. So with our partner, no problem on that.
Okay, we lost you for a second, but I think we understood the general purpose. So thank you for your
connect to station1.com.
Okay. A question again. So before asking you again a question, Aurélien, a question for Fabrizio. Which kind of sensors in the software you just mentioned that you are also further developing, orchestrating online inspection for printed parts?
So Blacksmith works through the laser, the precision laser incorporating the printing head in the industrial series. So for our X7 printer, this laser helps with the bed leveling and the reliability of the printer. But now we have launched this new platform in which the laser is used during the printing to scan the part as it builds layer by layer. So it's a positioning laser that is incorporated in the printing head. Then the software on behind the curtains, like we say in Italian, it builds up this map, this data point map to confront, to compare the actual produced part with the original drawing, the original file. And this can give this precision map for the tolerance, and also produce a report for the validation of the part.
Thank you so much. Perfect. I have a question maybe for Mathilde, or maybe you, Aurélien, also related to the redesign. So did you have to redesign the spare part for 3D printing, which are already designed for conventional manufacturing?
In fact, in most of the case, if we do some black metal, okay, copy paste, ISO design, the price is always higher, okay, with additive manufacturing. So if it is for spare parts, people are able, due to the low batch, to pay more, okay. So yes, we keep the same design, unfortunately, I would say, but the goal is to answer to the need of the requester, okay. But sometimes that's true that, for example, I have in mind some plastic cap, okay. In fact, sometimes additive manufacturing, as it is the beginning of the industrial story, we have only several materials, okay. We don't have hundreds of materials, okay. So we have to propose a material that is doing the same job minimum or better performance. So first we can propose, for example, this plastic cap with a material that we know. It could be nylon or ABS. And after, it's to ask to the people, okay, do you have some enhancement functionality you would like to add? Because we are doing the proposal with additive manufacturing, and sometimes it's very important to have the feedback from the operator saying, this cap is always breaking. In fact, the initial design is not so good. Okay, so can you just add this flange and this, and first it won't break, and it will enhance my job. And this is, I would say, the answer is yes. We do some black metal or black polymer. I don't know how to say. But it's possible. For spares, we are able to have a higher cost. But sometimes the success story is just listening. Okay, why do you have this part that is broken? Do you have some enhancement you could do? And with that, we are able to propose a very amazing part with additive manufacturing for spares.
Thank you so much. I think that that you answered several questions at one time, so that's perfect. Yes, I think that yes, there is one question related to the new metro, and are you able to give us an overview about some applications that are in the new metro cars precisely?
Not by now, without I would say, unfortunately, without the agreement of the final customer. It's okay. I would like, yes, to say, feel confident, you will have application in metro with additive manufacturing.
Just shall we take one more question? What do
you
question?
Yeah,
what do you think?
Just one more question, sorry.
Yeah, do we have one more question, like the final question? What do you think?
Yes, the final question can be I think it's a good summarize for that. So a question for Alstom again about the strategy of the technology development and production in the future. Do you see Alstom make or buy from external suppliers?
The answer is very, very easy. Jigs make, other buy.
Okay. Simple answer.
Indeed,
Yeah.
very simple, clear. Thank you for this. So thanks to all the attendees for being here with us today. We do hope that this webinar was helpful. And a huge thank you to our speakers, Aurélien, Mathilde, Fabrizio, Jocelyn. Wonderful teamwork. Thank you for this. You really made this webinar interesting and helpful. Thank you once again.
Yes, and I would like also from Alstom to thank you, Lisa, Fabrizio, and Jocelyn. I think that during the preparation of the webinar, we know more each other, okay, and we continue to support and to leverage the additive manufacturing, I would say, technology. Thank you, Mathilde, for this also your first webinar. So you did a great job, and it's only one of the hundreds of jigs that you are printing each month. So continue this way also, a very good job. Yes, and I thank you to all the attendees for these challenging questions. I hope the answer was interesting for all of you.
Thank you so much for everybody. And for some questions, we may reach out and give you answer by mail. So it's not going to be an answer that we're going to reach out as well from all we can do. And we're always available to support you in the additive journey. So thank you, everybody. Thank you, Aurélien. Thank you, Mathilde. It was a pleasure.
Thank you. Have a good day. Bye-bye.
Bye-bye.
Bye. Thank you.
Bye.